Hi everyone, I'm Trent Woodbury, the person who gets owned in fantasy football by Mark Coop. I have a background in engineering, and I'm here before you today because I wasn't doing enough math and programming on a daily basis. My capstone project was on clustering customer journeys. I got my data from and worked closely with ClickFox, which is a journey analytics company. So besides an awesome 80s band, what is a journey? Well, it's a step-by-step series of interactions with a product or service. An example of this is your day begins, you log into your mobile banking app, look at your account summary, check your balance, log out, and the day is over. I clustered these customer journeys using Latent Dirichlet Allocation, or LDA for short. LDA is normally used with natural language processing, so I had to do a bit of finagling to get customer journeys to work with it. Let me explain. I represented each journey as a separate document, and each event within the journey as a word in the document. I then fed these into the LDA model. What it output was different latent topics. Each latent topic is a linear combination of different events. So for example, if we look at latent topic number 2, it's mobile exit and mobile login. We can thus infer that this has to do with mobile events. Furthermore, we can infer that latent topic 1 has to do with web events. Beyond this, we can represent our journeys as a linear combination of different latent topics. So for example, journey number 2 is mostly latent topic 1. And this makes sense, because journey number 2 has to do with web events, as does latent topic number 1. So my results from this were, unfortunately, very uninteresting. What I had to do then was a bit of model moving. Instead of looking at different events as my words, I looked at transitions between events as my words. If you think of my first model as a graph, it's like converting the edges of this graph into the nodes of the graph of my second model. I then clustered this into 30 clusters, and the results looked something like this. Up top, we have 3 different latent topics or themes, and down below, we have the different events, or transitions between events. This color bar will tell us how correlated a certain transition is with a different theme. So for example, if we look at transition number 3, which is sure swipe login to mobile exit, we can see that it's very closely connected with theme number 3. My end goal, however, was to establish data-driven decisions based on these clusters. To this end, I analyzed my clusters to see what I could come up with. One example of this is the mobile disengagement cluster. This is a group of people who wanted to use the mobile app but didn't really know how to. If we look at the top 4 transitions associated with this cluster, we have people logging into their mobile app and logging out, looking at their mobile services and then logging out and logging back in. You get the point. My advice is we can classify these people and then offer them a brief tutorial on using the mobile app. We could then verify effectiveness of this tutorial by looking at what percentage of the people who underwent this tutorial transition from the mobile disengagement cluster to the mobile masters cluster. Another example of a data-driven decision based on these cluster results is the just show me the summary cluster. These are people who are logging in just to see their summaries. For these people, we could make the summary more prominent on the web page. If you look at the old Wells Fargo web page, the account summaries are really small. And interestingly enough, they have in beta a version of their website where the account summaries are much more prominent. And now I can see in big bold letters that I'm totally broke. Thank you very much. Does anyone have any questions?
One really just clarification question for me. In the clustering you're doing, was it attempting to cluster a given session or an individual over a period of time? Because in some sense, what it seems like you'd want to do is, as somebody starts a session, that you'd want to kind of predict what cluster you think they're in and modify that experience in real time. But so maybe just help me understand that a little bit more.
Right, okay. So my clusters were only composed of transitions. So that would be one event and then the next state that that user did. And I built a function that can classify a journey. and you could feed it a number of transitions or an entire journey, and it would tell you what that most likely is. Speaking of which, that function would break up the journey into different transitions, and that's how it would classify.
Okay, so then theoretically, you could classify the beginning of a journey to then adapt
Yes.
and, okay,
Absolutely.
gotcha. Thank you. Cool.
And kind of along those same lines too, were journeys unique to users, or was there sort of a super level above that of users who might have multiple different journeys, and how would you start tackling that problem?
So I got very scrubbed data. It didn't even have users associated with it.
So they could have, and
Yeah, so
You
I
don't know.
couldn't know.
cool, okay.
I think one interesting, so this was really interesting overall, one interesting application of this work would be to partner up with the network security people and see if you can figure out which users are trying to probe the website to figure out the attack points, you know, because presumably their
Yeah.
journeys through a website are going to be very unusual, are going to be outliers compared to the folks who are actually just trying to conduct business. So something
Yeah.
to think about.
I didn't find a cluster of people who were doing fishy things. Or maybe I just overlooked it. Thank you, guys.